So I'm going to run through the assignment that was actually posted on Tuesday of this week, the week of what, April 4th through April 8th, I guess it is. Whatever it is. Anyway, we assigned it, got it on Tuesday, and then we didn't finish it until Friday. So here's a quick synopsis of how to do it. So we're supposed to find a polynomial, and it's got these roots. And one of those I noticed right away is imaginary, the 2i. And we have to remember that imaginary numbers always come in conjugate pairs, which means negative 2i is also a solution. Conjugate pairs for imaginary numbers or complex numbers. Numbers like 2i have a real part of 0 and an imaginary part of 2. And its conjugate would be 0 minus 2i, and that's where this negative 2i comes from. And then we just use the factor theorem. The factor theorem just says if 5 is a factor, our solution, sorry, we've got to be very careful about this, 5 is solution, then x minus 5 is a factor. Okay, same thing with the 2i. If 2i is a solution, then x minus 2i is a factor, and same with negative 2i. If negative 2i is a solution, then x minus negative 2i is a factor. Now you'll notice here you get this double negative, and so that just becomes a plus 2i right there. Okay, and that's the polynomial. Okay, they want me to find the polynomial. There it is. Okay, and it doesn't say put in standard form on this, but we're going to, especially when you have factors that have imaginary numbers in there. We never want those things if we can avoid it. So let's go ahead and multiply these out. Now to do that, I'm going to multiply this pair first, the conjugate pair, x minus 2i, x plus 2i. When you multiply those, you take first, you distribute, just like always. But there's a shortcut for this, which hopefully will come apparent. And then my last distribution is negative 2i times positive 2i. So that's negative. 2 times 2 is 4, and I times I is I squared. And here's what I want to point out. When you're dealing with the conjugates and you're multiplying them, if you do the homework that is assigned when it's assigned, you would know this, by the way. This product, negative 2ix, and this product, positive 2ix, those two always disappear. This inner pair and this outside pair, they always just cancel each other out when you have a pair of binomial conjugates, x minus, x plus, 2i, 2i. Okay, and so really, all this math, all I had to really do is just take the x and square it. That's x squared. And then I have to take the 2i and I have to square it. 2i squared is 4i squared. Okay, it's just a difference of squares essentially. So regardless of how you do it, it simplifies to this very quickly. Be careful here. This is negative 4 times I squared, which is negative 4 times negative 1. I squared equals negative 1, so it's a positive 4. So there's the product of those two conjugate binomials. And then we can finish it up by distributing the x, giving us, let's put it in green here to distinguish it, x cubed. See, I could distribute this x now to the 4 and get 4x, but I'm going to do this multiplication next because I notice it gives me a negative 5x squared. And then I'll put this 4x in there. This just helped me put it in standard form as I multiplied. And then lastly, negative 5 times 4. So there we go. There's the polynomial that has the correct solutions. Let's do the same thing here with number 2. Again, solutions, root 5. Radical solution, conjugate has to come with it, negative root 5. And then we've got negative 3i. Let's put x equals. Imaginary number, got to have the conjugate. Let's put him in blue. Positive 3i. Alright, so let's, now that we know the solutions, it's always x minus and then the solution. X minus a double negative coming up, so it becomes positive. X minus negative 3i, that's the double negative, and then x minus 3i. Now, we do have to multiply these all together to get our polynomial in standard form, but we're going to multiply this conjugate pair, take those two answers and multiply them out. Let's use that shortcut now. Conjugates are being multiplied, so all I have to do is a squared minus b squared. It's just going to be, and I'm going to put them in parentheses, x squared minus root 5 squared, or x squared minus 5. The next pair are going to be, take the a value and square it, put a minus sign, take the b value, 3i, and square it. And that simplifies to x squared. And you got to be careful here. It is a minus, I'll run right off my paper here so you can see what happens. You've got the minus of a 3i squared. And so that's minus a 9i squared. That's minus, remember I squared is negative 1. So now you got negative 9 times negative 1. It becomes plus 9 right there. So those two factors now just have to be multiplied together, and that will give us our final result. Okay, I should move them closer together to make it kind of look nicer and neater, so I'm going to do that right here. So p of x, we have now simplified to this x squared minus 5 and this x squared plus 9. I'm going to erase some of this so we got a little space. And so now I just have to multiply those two together, and let's go ahead and clean the whole thing up. So this simplified to x squared minus 5 times x squared plus 9, and then we multiply x to the 4th, 9x squared, negative 5x squared, negative 45. And so x to the 4th plus 4x squared minus 45. And that's what p of x is. Simple enough. Let's graph these now. Here we go. These are quick ones. Notice how the polynomials are already in factored form. We just have to find out what makes each factor equal 0, and those are our x-intercepts. So I divide by negative 2 here, and I get negative 4.5. And so that's this point right there. The rest of them are much easier. X plus 1 equals 0, so x is negative 1. It's this point. And then lastly, x minus 3 equals 0, so x equals 3. That's this point. And that's almost enough to draw in your graph. You know, it's going to come down like this and do something, or maybe come up and do something like this. Let's just find the y-intercept. We'll know where it crosses, and then we'll be able to tell what the graph should, or where the graph should be. So here we go. Finding y-intercept, all you have to do is put a 0 in for x. So in each of these x's up here, we're going to put in a 0. And it becomes negative 2 times 0 minus 9. And it becomes 0 plus 1. And lastly, 0 minus 3, which I'll simplify to 0 minus 9, negative 9 times 1 times negative 3, or negative positive 27. And so this graph, and I've gotten really crowded here, is going to cross way up here at a positive 27. And that's generally enough to really draw your graph in. You can see you got that negative in front here. That's going to give this, when you multiply this, it'll be a negative lead coefficient, which means it does come in from negative infinity down here. Okay, but it's even easier to understand that, hey, if it's got to go through this and it's got to hit this point, the y-intercept and this x-intercept, it's going to have to connect those two, which means it has to go down here.